Welcome back to SmartSlides. In today's session, we'll talk about a key component of neural networks, the activation functions. These might sound technical, but they're basically the magic that allows a neural network to make sense of complex data and solve real-world problems. Let's break it down. First, let's understand what an activation function does. Activation functions are like decision makers for neurons in a neural network. When a neuron receives input, the activation function decides whether it should activate or not. This is how neural networks learn nonlinear patterns in data. Without them, the network would just process data linearly, which is very limiting. Now let's explore the main types of activation functions you'll encounter. We'll keep it simple and focus on the most commonly used ones. 1. Sigmoid function. The sigmoid function looks like an S-curve and squashes the input into a range between 0 and 1. It's great for problems where you need probabilities, like binary classification. The formula for this function is expressed as follows. For example, if you want to classify whether an email is spam or not, the sigmoid function outputs a probability between 0 and 1. Imagine your input is 2. Using the sigmoid function, the output would be 0.88. This means the probability of the email being spam is about 88%. 2. Tant, hyperbolic tangent function. Tant is similar to sigmoid, but better in some ways. It squashes the input into a range between 9 and 1, which means it's centered around 0. This helps the network converge faster during training. This function is represented by the following formula. For instance, you might use it to predict whether a stock price will go up, down, or stay the same. If the input is 1, the Tanh output will be 0.76. This means the stock price prediction is moderately positive. 3. ReLU, rectified linear unit. ReLU is the most popular activation function today. Why? Because it's simple and efficient. It outputs 0 for negative values and the same value for positive ones. For example, if you're processing image data, ReLU helps the network focus on important features while ignoring irrelevant ones. If the input is -3, ReLU outputs 0. If the input is 4, ReLU outputs 4. It's as simple as that. 4. Softmax function. This one is used for multi-class classification problems. It converts raw outputs into probabilities that sum to 1, making it easy to interpret the predictions. This function is represented by the following formula. For example, let's say you're classifying images of animals, cat, dog, or bird. If the raw scores are 2, 1, 0, the softmax outputs probabilities like this. This means the network predicts cat with 71% confidence. That's it for today's session. I hope this helped you understand activation functions better. If you have any questions or want a deeper dive into any of these functions, let me know in the comments below. Don't forget to like, share, and subscribe to SmartSlides for more AI and ML content. See you next time.